In this simple one-part mold course, I'll be taking you through how to take something like this, a master of a really cool glass object here, how to turn it into a simple mold like this so that you can create incredible copies that are custom and unique to yourself. And if this project isn't for you, the course still might be. Why? Because simple one-part molds apply to a lot of different projects. I use molds like this to create many copies of a fake starfish for different decor and other fun crafts. In this course, we'll be going over some of the techniques, tools, and thinking that you'll need to have when pursuing a project like this. But it's worth it. This single silicone mold right here can last a long time with an endless amount of creativity and fun all packed inside. One-part molds are the most basic form of mold making. When properly designed, they're the easiest to produce and easiest to cast in. Let's quickly review the benefits and downsides of one-part molds to ensure this is the right approach for our project. Pros: they're fast, simple to create, and easy to use. Cons: they cannot capture full detail, they require a flat base, and they may put strain on our silicone. One-part molds are our fastest option to getting a finished mold. They're usually done in a single pour that we can easily complete in just one day's worth of work. We can usually design our mold, build our mold box, and pour our material within just a few hours. Additionally, since the entire mold is in one piece, they are easier to create than other molds. We don't have to worry about the complexities of fitting two pieces together, accounting for odd pouring locations or seam lines. Since our mold is just one piece, it will also be easier to use. We won't spend time positioning mold halves together or dealing with other challenges that come up with more complex mold making. However, there are downsides to one-part molds. Since we have to remove our object and pour into just one flat section, we cannot capture detail on every surface of our master. If we need to capture detail on every surface, including the bottom of our master, then a one-part mold might not be our best solution. One-part molds also require a flat section on our master in order to work. We can work around this to capture as much detail as possible, but we will have to take extra measures to achieve this. In these cases, a two-part mold may be an easier solution. Finally, our one-part molds may require more effort when demolding. We often have to stretch and flex our silicone significantly to remove our master. That puts more stress on our molds and can lead to tearing and other issues if not planned for. For this course, we'll be creating a mold of this circular glass dish. This is a great first mold because of its simple shape, high gloss finish, and endless uses. We can use this as a coaster, dish, or for anything else that we want. We can also cast this out of a variety of materials, including resin, concrete, or anything else that we may have on hand that we want to cast in our mold. In order to make our mold, we'll need to make sure we have all the tools and the consumables we need on hand. Let's briefly list the basic tools and consumables we'll be using and discuss some options available to you. We'll need an X-Acto knife for cutting our materials, a hot glue gun for adhering our masters and walls, CA glue for temporary positioning, a pencil or Sharpie to mark the lines and make notes, a ruler or tape measure for sizing and cutting, tape for sealing and tacking, and a scale for measuring. We will also need some consumables, including isopropyl alcohol for cleaning, paper towel for mess management, graduated mixing containers for proper measuring, stir sticks for mixing, plastic cloth for a clean workspace, and our mold box material of either foam core or wood, depending on our preference. Keep in mind that our project can be completed using any mold box approach with proper planning. The exact tools and consumables you'll need will depend on the approach you choose. The tools and consumables listed here cover the vast majority of what is required, but may not be everything you need for your specific project. Our first step for each one of our projects is to scan our master. Scanning our master will tell us what we need to know in order for our molds to be successful and will serve as a reference for our mold design. Let's review what information we're looking for, take a look at our project, complete a master scan, and then create our mold design. When completing a master scan, we need to find out 1. What the overall size of our master is, 2. What material our master is made of, 3. What the basic areas of our master are. When we measure our glass tray, we can see that it's about 3/4 of an inch tall and has a diameter of 4.5 inches. It's made out of glass in this case and has a simple base with thinner walls around the outside. Based on this information, it's clear there aren't many challenges to this shape. If we scan up the sides, there aren't any undercuts, intricate details, holes, narrow sections, or any other challenges for us to deal with. With a good sense of the challenges ahead, let's dive into creating our mold design. We'll need to determine the size of our mold, its general shape, any specific techniques required to make it, and what properties we need from our silicone. Let's answer each one of these questions for our glass tray. In order for our mold to work well, we'll want about 1/4 of an inch to 1/2 inch of silicone around the outside of our master. That will make our mold's diameter 5 inches if we're adding 1/4 inch to each side. For our height, we can add the same 1/4 inch above our master's height to give us 1 inch. For our shape, it'd be ideal to keep the same circular construction so we aren't using more silicone like we would be if our mold box was square. While we're thinking about our mold box, creating a circular shape will lend itself to either a convenient solution like a bucket or a simple, light-duty material like foam core. In this example, we'll be using foam core to get acquainted with this material. From our scan, we know that there aren't any specific challenges for this master. That means we won't need any specific techniques like vents or sprues to make our mold successful. Our final part of our mold design is determining what we need from our silicone. Because the base of our tray is so wide, we don't need a very flexible silicone to easily demold our project. A medium firm silicone will help our mold keep its shape well and still make things easy to flex and remove. Since we're working with 3-dimensional objects and containers, we're going to use volume calculations to determine how much silicone we need for our project. This basic equation for determining how much silicone we need is our mold box volume minus our master volume equals our silicone volume. Let's calculate the volume for each one of these and then determine how much silicone we need. Referencing our mold design, we can see that our mold box will be cylindrical in shape and will be 5 inches in diameter with a 2.5 inch radius that's 1 inch high. If we plug our measurements into an online calculator, we get a total volume of 19.63 inches cubed. Looking at our master, we've got 2 different areas that we'll need to calculate our volume for: our base and the edges or walls of our tray. We can break down these volume calculations in extreme detail, but it's worth noting that this object is fairly small, and the amount of silicone we need won't greatly change with extreme attention to detail here. We can roughly estimate our part's volume and end up with enough silicone, no problem. Our glass is about 1/4 of an inch thick. That means our base will just be a small cylinder with a 4.5 inch diameter that's 1/4 inch thick for a volume of 3.98 inches cubed. We'll add another 1/4 on top of that to account for the rim to give us an estimated part volume of 5 inches cubed. Now we can take our mold box volume of 19.63 inches cubed and subtract our master volume of 5 inches cubed to get our needed silicone volume of 14.63 inches cubed. There are 21 grams of silicone per cubic inch, so we can use this equation to get the weight of silicone that we need. Our silicone volume times 21 equals the weight of silicone needed. In our case, that comes out to be 307 grams. We'll add a little extra since some silicone always stays in our bucket for a total of 350 grams of silicone. With our design complete, we need to choose a silicone that will work for our project. Let's review what to look at when choosing a silicone, the specific needs for our project, and then explore the options we have before making a decision. When we're choosing a silicone, we look at a few specific attributes to make sure it will work for our project. These attributes are 1. The elongation, or percentage of stretch, 2. The measurement type, 3. The demold or cure time, 4. The hardness, and 5. The cure type. Reviewing our mold design, we know that we don't need a substantial amount of elongation since our master is easily accessible and simple to remove. We have a scale at our disposal, so the measurement type, either by weight or by volume, does not impact our decision. However, if you do not have a scale, then choosing a silicone that can be measured by volume will be important. We aren't in a specific rush on this project, and since it is a one-part mold, it should be complete after just a simple overnight cure. That means the demold time for our silicone can be anything from 3 hours to 24 hours. To determine the shore hardness we need, let's jump back to our mold design. We determined that we need a medium firm silicone to help our mold hold its shape well and still make it easy to flex and remove. Within each scale, there are numbers ranging from 0 to 100, with 0 being the softest and 100 being the hardest. A medium firm silicone often falls anywhere from 30A to 40A on the shore scale. We could go slightly softer without any major issues since our project is so straightforward, but for now, we'll stick to what we have planned. The last attribute to look at is our cure type. If we plan to use this mold in any food-related way, then a platinum cure silicone that is tested to be FDA compliant would be a good idea. Since this may be a tray used around food or beverages, we'll use a platinum cure silicone to be safe. For a more detailed look at the different cure types and when to use each one, just hop back to the Mold Making Basics course where we cover this topic in greater detail. When we look at our silicone cure type, we do need to consider if our master will cause any cure inhibition. Our glass master won't give us any issues, but make sure to review the list of materials that can cause cure inhibition before making this final choice. If we review our needed attributes, we can see that we need a platinum cure silicone with a hardness of 30A to 40A. Since the other attributes don't affect us in this case, we can find a solution that fits just these two conditions. That means the best silicone for this project will be our Plat 40 silicone. It's a platinum cure silicone that's measured 1-to-1 by weight or by volume with a shore hardness of 40A. We also calculated that we need 350 grams or 0.77 pounds of silicone to complete our project. Looking at the website, a small 2-pound kit of Plat 40 will do the trick. It's now time for us to build our mold box. For our example, we're planning on using a foam core mold box, but remember that you can follow these same principles with whatever mold box material you may have on hand. We'll be using every tool that we previously listed here in this process. So if we don't have all of those items, then let's take a moment and get them all. Because our tray is circular, we're going to make a circular mold box. A square mold box would work just as well in this situation, but it will require more silicone than we previously calculated. This isn't a big deal, we'll just need to go back and do that calculation again if we choose to do so. To start, let's grab a fresh sheet of foam core. We can see that each edge is perfectly straight. These are called factory edges, and we'll use these to our advantage when measuring and gluing. We know from our mold design that we want the height of our mold to be 1 inch. To make that happen, we'll need our mold box walls to also be 1 inch high. With our height determined, we need to figure out the lengths of our mold box walls. If we are creating a square mold box, then we would need a few different measurements and cuts. But since we're creating a circular mold box, we need just one measurement, the circumference of our mold. Using an online calculator and plugging in our mold's radius of 2.5 inches, we can see that the circumference of our mold will be about 15.75 inches. We'll add about 1 inch to that measurement so that we can trim our wall down to the exact size later on, giving us a length of our wall of 16.75 inches. With our 2 dimensions determined, we can measure and mark our foam core. When measuring our foam core, we'll want to use one of the sheet's factory edges to ensure our measurements are equal. We'll also use the factory edge as the bottom of our wall so that the edge that meets our base fits without any gaps. Once our foam core is marked and our measurements are double-checked, we can cut out our piece and separate it from the rest of the sheet. In order to make our foam core circular, we can use a trick. If we remove the back of our foam core on just one side, we can now bend and snap the foam center without damaging the opposite side. All we'll need to do is apply a little bit of gentle force to make this work as we work our way along the piece. With our wall cut out and pre-bent, we can look at creating a base for our mold box. We'll also use foam core for this since we have a sheet on hand. Our base does not need to be any specific dimensions as long as we have enough space for our mold and room to properly glue things together. An extra ½ inch around our mold box is usually plenty. With our base in hand, we can set our master in for reference and then mark around the perimeter to give ourselves a guide for placing our mold box wall. With our master taken back out, we can now tack our mold box in place using some CA glue and some accelerator. We'll hold our mold wall in place, apply a small amount of CA glue to where our wall meets the base, and then lightly spray that spot with some accelerator. After 5 to 10 seconds, we should be able to let go and then move along and repeat our process. If we don't have any accelerator, that's okay. We'll need to just wait a few extra seconds while the CA glue dries before moving on. Once our wall is in place, we can trim off any extra that we have to make sure our wall meets cleanly to itself. Although our wall is in place, we still need to properly seal all the seams to avoid any leaks. For this, we'll use a standard hot glue gun and apply a bead of hot glue all the way around our mold box, including the seam where our two sides meet. That completes our mold box build for this project. We'll give this a little bit of time to completely dry and cool down before we set in our master and move on to the next step. With our mold box complete, we're ready to glue in our master. Let's review some important steps and a couple of tips to make sure we set ourselves up for success later on. The first thing we'll need to do is make sure our master is clean. Any debris or dirt on our master will transfer into our silicone mold and become a permanent part of its design. However, it's not just dirt and dust we need to watch out for. Fingerprints, smudges, and other hidden marks will also show up in our silicone mold. To avoid this, we can clean our master with isopropyl alcohol or another cleaning agent that we feel comfortable with, as long as it does not include any cure-inhibiting chemicals. In our case, this glass master will give us a high gloss mold, but will also show every little imperfection. Taking a little extra time to clean things will ensure every casting in this mold is perfect later on. With our master cleaned, we can move on to getting it in place. There are options for how to affix our master to our mold box, but remember that the best option is the one that you have on hand that will get the job done. For the vast majority of situations, using a little dab of hot glue will do the trick. With our master in hand, we can apply a small amount of glue to either the master itself or the base of our mold box and then press down on our master to make sure the two are as flush as possible. If we don't get the base of our master flush to the mold box, then the silicone will leak underneath and give us more cleanup to do later on, or in the worst case, pop our master loose, ruining our mold. In our case, we have a master that has a pretty large area where we can glue it down. With this in mind, we can limit how much silicone leaks underneath by applying a small amount of glue near the edges of our master to serve as a better barrier to the silicone. With our glue applied, we can set our master in our mold box, apply some pressure, and let it dry. In this situation, our mold box walls are short, and we can easily set our master in after everything is constructed. But keep in mind that the larger and more complex our mold is, the better it is to affix our master before we build our walls. No matter how much we plan or prepare, sometimes things will go wrong. Our master may float out of our mold box may spring a leak, or something unexpected comes up. It won't happen every time, but we can count on it happening at some point for sure. Let's talk about some quick steps to take when something goes wrong. The most common problem we'll run into is a leaking mold box. As much as I would love to show you an easy trick to fix any leak, the truth is there really isn't a good one. A leaking mold box is really something we'll work to mitigate, but isn't something we can just easily fix in the moment. The first thing to do is get a trash can or other receptacle to our workstation. We're not going to throw away our mold, but we may have silicone running out onto our workstation, and a trash can can help with that. To help slow our leak, we can grab some clay and apply it to the area. Although the clay won't stop the leak, it may buy us some time. Using hot glue, it won't work, since the melted glue won't have time to harden before the silicone pushes it out of the way. With the time we've bought, we can decide what to do. The key factor in that decision is going to be the open time of our silicone. If our silicone cures quickly, then a small leak may not be a large issue. The silicone may reach a gelled state before a critical amount has run out. However, if our silicone has a longer open time, we can choose another option. We can stay with our mold for the remainder of the open time and just do our best to put the leaking silicone back into our mold. Although this is a painstaking option, we can salvage our mold if we have the patience. If we don't have the time or patience for that, we can dump our silicone out of our mold and into a clean bucket. With the remaining open time, we can do our best to fix the leaking area before pouring our silicone back into our mold. However, this isn't a foolproof method and does require a good amount of remaining open time to work. Leaking isn't the only issue we may run into. Sometimes the master we thought we properly glued into our mold comes loose and floats to the top. We can handle this situation just as we handled our leak. We can remove our master, clean it off thoroughly, pour our silicone back into a clean bucket, clean out our mold box, and then go about affixing the master if we have enough time. Mistakes and issues are a part of the learning process. We can do our best to avoid them, but sooner or later, we'll have to learn the hard way. There's a lot to consider when we mix and pour our silicone. In fact, there's just too much to cover here in this course. For a more comprehensive look at this process, we can jump back to that section in our Mold Making Basics course. However, let's review a couple key principles briefly before moving on. First, it's important that we properly measure our material. Silicones can be measured in different ratios in different ways. That can be 10:1, 1:1, or even 100:85 by weight or volume. Make sure to read the instructions for your specific material. Secondly, we need to properly mix our material after we've measured it. That means doing more than just stirring in a circular motion. We'll need to use other techniques like folding and a figure-8 pattern to mix well. We'll also need to scrape our container and stir stick to make sure everything is properly combined. Deciding whether or not to degas our silicone depends on our specific project and if we plan to pressure cast our material. For this project, we won't be degassing our silicone, but if your project is different, then it may make more sense for you. Lastly, we want to make sure that we pour slowly in one spot away from our master to make sure we limit the amount of air we trap on or near our master. This is critical to ensure that we end up with a good mold. Let's start our process by grabbing our Plat 40 silicone and a graduated mixing container. Since we won't be degassing our silicone for this project, we can use a container that fits our silicone and will be easy to mix in. Our Plat 40 can be measured 1:1 by either weight or volume, but to ensure we only use the amount that we need, we'll measure out our silicone by weight. Let's grab our scale, turn it on, set our empty container on top of it, tear our scale, and then start measuring out the A side of our silicone. Since we're looking for 350 grams total, we'll want to measure out half of that for our A side and half for our B side. That means we want 175 grams of each. Once we have 175 grams of our A side, we can tear our scale and then measure out the same amount for our B side in the same container. If we wanted to add any silicone dye to give our mold some color, this would be the moment to do so. For our example, we'll keep the natural color of our Plat 40, which is a semi-translucent finish. With both sides now in our container, we're ready to start mixing. We'll mix this amount of material for around 2 minutes, following the proper techniques we've covered to ensure a good mixture. If we were mixing a larger amount, we'd need more time to properly mix that material. Since our silicone is a medium firm hardness, its viscosity will be slightly higher, meaning we will be introducing some air as we mix. Since our mold is shallow, our silicone won't have any trouble releasing this air, but it's important to know that for a deeper mold, or if we're pressure casting, we'll want to degas this mixture for best results. With our silicone mixed up, let's finish this phase of the process by pouring it into our mold. It's best practice to pour away from our part so that we avoid trapping air anywhere on its surface. This may be a little difficult since our space to pour isn't very big, but that's okay. If a little silicone creeps onto our part, we don't need to worry about it. After we know where we're going to pour, let's tip our cup and let just a little bit out. Once we know where our silicone is heading, we can find the right angle so that we are slowly filling our mold and allowing our silicone to flow around our master. If we dumped our silicone on top of our master quickly, there is a good chance we'd trap some air somewhere along our part and ruin our mold. As we continue to pour, we'll watch for any areas that may not be filling up properly, check for any leaking, and continue to pour our material until we've reached the top of our mold box. Once we've reached the top, we can slow our pour and twist our cup to cleanly stop our pour. Another quick check for leaks or other issues, and then our pouring is done. With the right amount of prep work, pouring a simple project like this doesn't need to be complicated. We can follow our best practices and end up with a great result each time. Now we can let this mold sit undisturbed for the duration of our demold and cure time. We've successfully poured our silicone and waited for our demold time to elapse. Now it's time for us to test that our silicone is cured and then begin demolding. To test that our project is cured, we'll use a stir stick and gently touch the exposed surface of our mold or witness cup. The silicone should feel firm with a little bit of rebound. Remember that the harder our silicone is, the more firm it should feel when cured. Beyond the firmness, we want to make sure that our silicone isn't tacky. To check for this, we can see if our stir stick grips or sticks to our silicone as we lightly press against it. If there is any grip, then our silicone may need a little more time to cure. In our case, this mold is properly cured and ready to demold. The start of that process is removing our mold box. Turning our mold upside down, we can remove our base with some slight force and then tear away our mold box walls to complete this process. Our foam core mold box has served its purpose and we can discard it at this time. If we chose a more durable mold box option, then saving our material to reuse is a smart move. Although we use glue around the perimeter of our master, we can see that there is some cleanup we'll need to do before we remove our part. With our master still in our mold, we can take our X-Acto knife and trim away any flashing that's found its way under our master. We do want to keep in mind that our master does have a rounded base. We don't want to trim away that section, so we'll only focus on the very thin flashing that isn't important to our mold. With a little bit of tension on our material, our X-Acto knife will easily cut through the silicone to give us a clean finish. With our flashing trimmed, we're ready to demold our part. Let's start by gently flexing our silicone near the edges of our master to introduce a small amount of air. We can repeat this process around the perimeter of our mold and then more aggressively pull it away from our master after everything has been loosened. With that, our glass tray is out of our mold and we're done. This mold is complete and ready for casting. The high shine on the inside of our mold comes from the same brilliant finish on our glass. That means that our castings will come out glossy and beautiful. What we choose to cast in our new mold is up to us. Resin, concrete, silicone, and many other options are at our disposal now since we went through the process of creating our own custom mold. If you want to stay in the know, then sign up for our email, text, and follow us on social where you can see the latest and greatest projects, courses, and other beautiful things that people just like you are making every day. Thank you again for joining us on this course, and we'll see you in the next one.